Hello, everybody. Hope your week is off to a great start. And here we are with another session of data analytics. We continue the example we started last session, the first example, really, that needs data preparation. And so we started working on that thing, data preparation 2. But here we continue on data preparation 3. As far as you may remember, last session we prepared the input data, and we always did continuous comparison between the new case and the previous admission case, and we tried to get it as a model, because over there the data was prepared and we just fed that data to our model. But here we started to working on that. We created the input data, some sort of normalized, but still it needs some more work that I will tell you about. And finally, we got to the output layer. But here, in data preparation 3, you see some more explanation. Let's read it together. In this study, not all the positive and negative returns are considered as actual upturns or downturns. However, for the positive returns, there is a lower bound of 1/5 MP, and for the negative returns, there is an upper bound of 1/5 MN, where MP and MN are means of positive and negative daily returns of the stock during the training year, respectively. It is something that, again, the person, the finance person, the person who is supporting your data analytics team in terms of financial knowledge gives you this thing. And it's very easy, because now you will see we are going to do this together. So just have it in your mind that we have a 1/5 minimum of positive returns and minimum of negative return. And I will show you the data we created last session. Okay. I'm very happy that I was able to provide you with this example, because before you are graduated from data analytics measure, you need to have such a project, homework, and something like that. So you can feel the weights of learning more on that. This was the table we got to last session, but according to what I just read for you, it says these returns are not acceptable. Why they are not acceptable? Not acceptable. You remember, we are not making a regression model. It's a classification model. We want something straightforward. Upward, downward, neutral. Okay, so here it tells us about that thing. It says you consider the number that you see here as upward if it is greater than 1/5 of the positive returns of this training data that you have. I'm going to do this for you now. You see here, I'm going to calculate the mean of positive returns. So it's very straightforward. It says that calculate the mean of positive returns. 1/5 of that thing is the threshold to decide if a trend is upward or not. So let's do it together. Put it here. So I put 1/5 of average of 1/5 average, but average if average of these things. Okay. And you are caught up, yes? Very good. So before you started this session, you had to review it and, okay, very good. Now we are here just trying to define them in a better way that to tell us which one is upward, which one is downward. So we are going to calculate the average of positive return. So that's the reason I have used average if, not average of this range, average of this range if they are greater than 0. I close it, and that's it. So it is 1/5 of the average of positive returns due for the training period. Here, I'm going to calculate 1/5 of average of negative returns. So again, I think that we can record class is a huge thing. That's great. Okay. And here do I put the criteria, smaller, 0. You can do all the things with R, you can do all the things with Java, but since I'm here more focused on the data preparation, so I do it with Excel so you can see the results in a more tangible way. Okay. And now here we have the 1/5 of return. Now that we have here we can create that type of thing. But before you start, I have a question from you. For the previous example, we used logistic function, and the output of the neural network was designed to be 0 and 1. So logistic function was very good. We said if it is greater than 0.5, it is 1. If it is smaller than 0.5, it is 0. But here we have 3 conditions. We have upward, downward, neutral. If the return is greater than this tiny number, it is upward. If it is smaller than this, again, tiny number, it is upward, downward. And if it is between them, it is neutral. So we have 3 states. Could we still use logistic function or not? Yes, still we can use logistic function. We can use for 10 categorized, 100 categorized, 1000 categorized, as we discussed it before. But as some sort of variation, new experience, let's use another way of doing it. And instead of, and if we want to use the 3 classification problem, try classification problem by a logistic function, here we need to say if it is smaller than something, get 0. If it is greater than something, get 1. And if it is between them, get 0.5. In that way, we cover that thing. But it would be better, I guess, if we go for 1, 0, -1. When it is 1, it means it is upward. When it is -1, it means it is downward, and otherwise it is 0. So let's do it together on 3 steps that I just mentioned. And again, you can do it. Let me write it for you so I can feel better. In that way, I feel more. Okay, so see, my friend, logistic function was a function that changes between 0 and 1, logistic function. And we learn it together, and it can be used for any number. But when it is used for a trie classification, the definition should be a little bit different. The definition would be something like that. If x greater than, for example, let's say 75, then class is 1. When x is smaller than 75, greater equal than 25, then class is 0.5. And if x is smaller than 25, then class is 0. You see, it's not bad because still you are classifying it into 3 categories. But let's try another thing that when, for example, x, instead of having 0.50, it's much better to have something like, for example, 1, 0, minus 1. You see, it feels better. We just need to use a function that instead of the range of 0, 1, the range is -1 to 1. And we have that function, hyperbolic tangent, that it is that we are going to talk about. And it's very easy. You just need to write it in R. But if you want to write the code with other programming languages, you need to, okay, define it. Let's return to our Excel file. And now, my friends, take your time on the file you have in front of you and create the correct output, that upward, downward, and neutral, according to the things that we just. If it is upward, put it 1. If it is downward, put -1. Otherwise, put 0. And I also do it, so you can check it with me. If the return is greater or equal than 1/5 of the positive returns, then return 1. But if the return is smaller or equal than 1/5 of the negative return, then return -1. Otherwise, return 0. Close it. And here we see the answers. Now we get it for the rest. And now everything is ready for your work. And again, the main reason I chose this example, I want you to use such big type of data that you don't feel, or you always did some small problems. Okay, now we see this is greater, so it is 1. Why it is 1? No, it shouldn't be. There is something wrong. Okay. greater. Oh, the reason is that I forgot to freeze them. See, because they are fixed number, H3 and H4, they need to be frozen. $and $, for the formula, because I copied and pasted over the rest of the page. So I need to freeze them. Nice, okay. I'm gonna copy and paste it to the rest. Bravo. Now let's check. It is 1, it is greater 1, smaller minus, and like that. Now you have the output layer. Now you have the output layer, and now you are ready to do the homework tree. For homework tree, although you can do it on your own, but absolutely I recommend do it in a group of 2 or 3. Just let me know about the groups you have, and I will explain the details of the homework. What would be? It would be on this data that you have. So it is the output you have. Here, you may ask, Milad, is there necessity to normalize this data that we have here? Because they are, all of them are of the same type. All of them are the same metrics. So there are not, for example, one of them is age, the other one is income. All of them are something, and the numbers are all crossed. Is there any need for normalization? Again, I recommend normalization, because now it's going to be your job, because you are going to, that's the reason I'm asking you to do this homework with your other classmates, because I want you communication with each other and see what is the result of other people's trials. In fact, this is a learning homework. It is not a testing homework. It is just give you a platform to improve your understanding of neural network. So yes, I recommend do the normalization. And you can do what? You can do, you do one training with normalized data, and you can do one without normalizing data, and just compare the results. And you have everything, and you design your neural network according to this instruction I would put for you in the announcement that I will post on Wednesday. And you will do it, and you start real applications, because it is the General Motors stocks prices, and it is something that it's possible for any other things. You just run your model, and sometimes it gives good numbers. And let me also give you the heads up. I don't want you to create a perfect neural network. No, I just want you to practice. No matter, even if your neural network results are terrible, no matter. I just want you to put time, talk with your friends, see different types, and also sometimes maybe you get hard time in making the results converge, in finding some structures that work. I just want you to give that type of things. And it cannot be more real. It cannot be more real. The data is real. The model is real. The computer is in front of you. There is no simplifying assumption here. And you just fit them, construct it, and get the results. And you check how much your model works. And of course, we will discuss it. But according to the plan we have, today is the last day we talk about neural network. Because next session, you are going to start working on that. And you start creating your neural network, running it, because it's a homework session. And Friday is also no class day. And next week, we start with new topic. And I guess neural network gives you a very good glimpse of a real experience with data analytics, and how much when you know the basics, it's easy to handle and work with numbers. Okay, but I want to help you with making a better neural network. So in the remaining 30 minutes, we are gonna have a very good discussion on neural network model building. First of all, any question on this data preparation phase? Okay, so the things, we created our neural network with very simple structure, with just 5 inputs. But let's talk about other inputs because you may need them in creating. It depends how much you are interested. I'm not going to force you to use that. If you are interested, you go and check, you learn them. And of course, it gives you so much perspective on the area and gives you better foundation. If you are not interested, still the model that I gave you with just 5 inputs can work. But at least let's review these things together to see what other things are meaning. Neural net formula, we already know about this. About the data, you are a professional way. You are very good with the hidden. So when you put nothing, what is the default value of your structure? Only one layer, hidden layer, and only with one layer, the easiest one. The second one, so the first new parameter that we are going to discuss is threshold. When you leave this threshold part empty, it put for you 1%. But let's see, what does it mean? What does this 1% threshold mean? Threshold is a numeric value, always in computer, because you have passed Java and you know how much it is important to specify the type of the values you are working with. Although, for example, in R, you don't need to specify it. But when it says a numeric value specifying the threshold for the partial derivatives of the error function as a stopping criteria. Since it is mathematical, forget about this one. Let me tell you about the practical definition of these things. It works about error and about stopping criteria. When you stop, when the errors are gets higher and higher, or when the errors gets smaller and smaller. When errors gets smaller and smaller and you find no improvement, you stop. Makes sense? So I want to tell you, don't get intimidated by this structure. Today we have a lecture by a colleague, and there was another model. Maybe the model was intimidating, but behind that, when you know all the basics, the foundation is good, maybe in 2 hours you can learn all that model, all that library, and put everything to work. So when you see such a thing, it's not, wow, what I'm gonna do with this? Just makes sense. It says it is something to put an end to that training process. Why the training process should be stopped? Because there is no improvement in the training process. So when the improvement is less than 1%, stop. What is the measure for measuring the improvement in learning? The error. First, it calculates the error. And how we calculate the error? We have talked about all those functions that calculate the error. When the improvement in the error is less than 1%, stop it. It isn't worth it anymore. That's much easy. So the name is threshold in neural network, but it's nothing that, for example, if now your function is error is 100, and the next one is 99.9, it would stop it because the improvement is less than 1%. Now, if you want to get better, not better, if you want to get more strict, if you want to get a stricter training, you need to decrease this number because it would be very strict, and even it would be greedy for example, 1,000 of improvements. I have put this explanation for you also that says the same thing. The model will continue to iterate and try finding the best solution. That is, what is the best solution about the ideal weights? Because it is the meaning of the training for each neuron at each layer of N till it reaches a point where the overall error of the model is not reducing by more than the given threshold value. If threshold is 1%, then if change in error at a given step of iteration is less than 1%, the model will stop further optimization. So in the previous one, we left it empty, but you can work on that and to check the results. Okay, so now we are good with even threshold. And there are some questions. Sometimes people who are employing data analyzers, especially who are just graduated from school, they ask. They don't ask you to run, for example, but usually they ask, what about the threshold in the error? Just have the concept. And don't forget that one point that I told you is speculation in this field, because it is very vast, millions of models. It's not possible to cover everything, but it's possible to be able to get quickly the main points of the things. You are a driver, for example, okay? Suddenly something happened. If you are a professional driver, if that case is something that is happening to you for the first time, you can handle it. You cannot say, oh, I have never driven in 3 a.m. Okay, now you have to drive at 3 a.m. Although all your training have been in the morning when you were fresh, but sometimes you need to handle that situation. Exactly to other fields. When you know the rules, when you are experienced, okay, 3 a.m., yeah, I can handle it. I can handle it, although it's my first time. You need to do this with that library of Python. Although I have not worked with that, but I can get it in 24 hours. Just I will go and check it because every facts are the same. All of them are the same. The models are the same. See how much of the things that we discussed today, discussed for neural network were the things that we have discussed before. So after neural network, you must be a better learner for others. And that's the reason the next topic that I'm choosing for the class is very far from these things because I don't want any clashes. So it gives you a better foundation. Okay. And now you are good with threshold. Let's go with the step max. And so another thing with thresholds. Threshold works with convergence. Threshold works with ending. What about step max? Do some speculation. Step max, it is something should be about number, and more than that is not possible. And it is a step. It should be something like repetition, something like that. Let's see what happens. The maximum steps for training of the neural network. Reaching this maximum leads to stop the neural network's training process. What is the first weights you have for your neural networks? What are the first set of weights you have for your neural networks? As we discussed it before, all of them are random numbers. But random numbers get updated until good results achieved. Okay, but you are not going to update it for infinite time. Am I right? Indefinite time. Indefinite time. You are going to run it for 10 to the power of 5 times. It means 100,000 times by default. Okay, what happens if the threshold reached that 1% before this number? Okay, it would end it. Now go and check the steps. Now you know what does a step means in that diagram they got from plot. It would stop it. Stop, because I have reached the threshold. What happens if you don't reach the threshold, but the step max achieved? Again, it would stop it. That's the meaning of non-convergent. So you see, it's not something very special. So when it says it's not converged, it means that the threshold didn't achieve. Why? Sometimes it converges and sometimes it doesn't, because the first start is random. Sometimes the first start is close and it can handle it. Just if you come here and increase the number of step max from 10,000 to, for example, 200,000, it works. It makes it convergent. So again, my friends, see how much the concept behind this complication is easy. The neural net package updating the weights and repeating until either convergent defined by threshold or a step max is reached. You always have your neural network. About the rep, forget about that. At this point, you don't need it. Still, it's good for you to manipulate threshold, to manipulate the step max, but for rep, just leave it as default value. What about start weights? My friends, what is start weights? So far, how did we handle start weights? All of them were random. So when you don't put anything, it is random. But there are some professionals who are very experienced with some neural networks and they don't want to start randomly. They have very good start for them. So they give those inputs here and they would be vectors. As you can see here, a vector containing starting values for the weights set to null for random initialization. Of course, if you have good start values, it would be better to give to your neural network, for example, from previous training. But if you don't have, it started with random. So if you don't put anything like the previous examples we did together, just put random numbers. But you can put your own. About learning rate limit, we talked about these things. You can have put higher numbers, you can put low numbers, and everything that we discussed before works here, but still, I'm not recommending putting anything here. Just leave them null. This learning rate factor, leave it null. About the life sign, leave it. It doesn't mean they are difficult. No, no, no. At this phase, you don't need it. They all are easy. And we get to algorithm. We get to algorithm. Algorithm is the main, is the software of the neural network. Is the software that it is what computer scientists, pure computer scientists work on that, pure lean mathematicians work on that, and they come up with algorithms. The algorithms that do all these optimizations, that make the weights in a way that it do the predictions. All this repetition, derivatives, and they are complicated. And it's a string containing the algorithm type to calculate the neural network. The following types are possible. Backpropagation, it is the default. And these things that you see, you can put. There are also other things you can get, but they are on the standard package. And again, you can just change the name and check the results. About the error functions, we have talked. The default one is SSE. The activation function. The activation function, logistic. So far, when you leave it alone, not leave it alone, when you leave it empty, like the previous example we have had so far, it put logistic. Logistic is the one that we have discussed together between 0 and 1, but there is also another one. There is also another one, as you can see here, tangent hyperbolic. It's a function like this. So when you give it, instead of, if you leave it alone, if you leave it empty, it considered logistic. But if you want different range of outputs that you are going to experience with your homework, and please feel comfortable to consult me while you are doing the homework in case you need consultation. It is the tangent hyperbolic that you can see the outcomes are between -1 and 1, and it is of course under control. Why it is better when the number of, it's always better. It's always better because it provides you with a better range, 1, 0, and -1. Okay, and still don't consider these things. So now at this session, in this quick review that we just had, now you have more power over your neural network to teach it. And I'm going to write these things in the explanation of the homework, but pay attention. I'm not asking you to create a perfect neural network. You are not going to run the model in the market. I just want you practicing and get something in a practical way for your homework. And of course, you are allowed this time to completely work together. Not group of more than 3, but I suggest group of 2 to 3. And please let me know also about that thing. And only one submission would be good for the project, because there maybe are other questions that you need to answer them on your own. Maybe, for example, some conceptual questions and all those things. And I'm telling you, just the project part is cooperative. If there are something that asking you about what is this, what is that, do those things on your own. Okay, so the activity that I'm asking you to do is exactly the same things that you are going to do with neural network. If there are 3 categories of 1, 2, 3, okay, so we have exactly here 2 categories of uptrend, downtrend, and neutral. And the most important target is the first category. So we want to find the uptrend ones. Okay, what is the hit ratio of a random classifier? What does it mean? Imagine you are working in the market randomly. You randomly say if this trend is upward or not, randomly. What is the hit ratio? I don't want the answer from you now. First, I want you to do it, simulate it, and just do it with Excel. What do you want to do with Excel? You need to create some cases, some random cases of 1, 2, 3, and randomly pick them as the uptrend. See what is the hit ratio. Why I'm asking you to do this? Because when you run your model, you want to see what is the accuracy of your model in predicting uptrend, neutral, and downtrend. For example, you come some number, for example, you come to 25%. So in that way, if it is over the hit ratio of random classifier, it means that you have created some sort of wisdom in your model. Otherwise, you need to work on that. And it gives you so much fun if you are interested in the field and you are trying to figure out something. And if you are interested, again, you can book some office hours and we can discuss it together. But let me give you the answer before you start that practical part. See, the heat ratio when they are 3 is 33%. You randomly decide if something is 1 or not out of 3. So on average, in long term, the heat ratio for a random classifier is 33%. So if your model comes, we will discuss it. We will discuss it. I don't want to spoil the points. But if you come to a model that can, for example, do it with 49%, it finds out uptrends very well. That's awesome. And I suggest follow that things for getting new data. They are all available. Just now go and get the data for 2021 and run your model. And maybe that would be a great start to create some application in that way. And always feel free to consult me. Okay, my friends, start working on this. Since I don't have anything more to tell you on this, I stop recording, but I'm available here for your questions. So now you are working on the fact that what is the heat ratio of random classifier with Excel. Create 1,000 randoms and do it. Because you can do it anyway. But the results in long run should be 33%. You can do it, create 1, 2, 3 as the classifier and pick them randomly. Any way you want to design it. Now you should be very good with these things. Or you can, again, you have 1, 2, 3 assignment, and after that you assign again 1, 2, 3, and the ones that are equal, they are the ones you want. Because these things are not one. They're the same way. Okay. Thank you. I'm still available. I'm just stop recording because saving storage.